So now we are in chapter 8, modeling change, more calculus. The first lesson, it's about the area and volume. It's very easy. It's just about formulas, and we will do some example. So I will start first with the area. Already we did the area in the preceding lesson with the integrals, but we were doing just the area between the x prime or x and the function. So here in this lesson, we're going to do the area between two functions. So if we have the two functions f of x and g of x, and you have x between a and b, the area between the graphs of f and g is given by the following formula. Area between a and b, it's the upper boundary minus the lower boundary. Already I said that in the preceding lesson. Let's do an example. Find the total area enclosed by the graph of x is equal x3 minus 2x plus 1 and its reflection in the x-axis. Normally, they will give you two functions or like this case here. And to be able to graph it, we're going to use our calculator. If f of x is x3 minus 2x plus 1, when I do the reflection with respect to x prime of x, it means going to be minus f of x. So it's going to be the other function g of x minus x3 plus 2x minus 1. So when I draw its inverse function, I can see that I have two parts here where I can calculate the area. So I have this one and I have the small one here. So first of all, the area of this part here, it's between the x of A and the x of this point here. The x of A, sorry, because I did the coloring, cannot see it anymore. So it's integral between minus 1.62 and 0.62 of whose upper here, it's f of x minus g of x plus the area of g of x minus f of x between 0.62 and 1. You can see here that when I'm doing the sum of the two consecutive parts as an area, you can see that those numbers are the same. And all what we need to do now is just we replace f of x minus g of x, we replace it plus g of x minus f of x. I do the calculation and I got the integral of this expression plus this expression. We know how to do the integral of 2x3 is to x4 over 4 minus 4x2 over 2 plus 2x. So we know how to do the integrals. We replace, you know how to replace also, it's upper boundary minus lower boundary, and in the end we're gonna get, this is the final answer. When you're calculating the area, you need to write the unit, it's unit squared, because the area is the unit squared. Let's do another example. If I need to find the area of the region bounded by the graph of y equal x, so I can see this is the purple one, and y equal x2 over 3, with the two vertical lines, x-axis, it means this one here, and the line x equal to 3. Now, if I want to see this area here, the region that I will have, it's all this one here. But if I want to really find its area, I cannot find it directly in one step, because if you want to see which one is upper, which one is lower, you will be confused here, where is upper, where is lower. So I need to decompose it in two parts. I can see that I have here the part here. I can see that this is my upper boundary minus the lower boundary, it's x prime or x, and it's between what and what, it's between 0 and 1. So the area of the first part is the area between 0 and 1 of x exponent 2 over 3 minus 0, it means x to exponent 3 dx, plus integral between 1 and 3, upper minus lower, so it's 1 over x minus 0 or 1 over x dx. We know how to do the integral of x2 over 3. It's plus 1 over the answer, so it's 2 over 3 plus 1. It's 5 over 3 over 5 over 3, so it's going to be 3 over 5 x 5 over 3 between 0 and 1 plus, and we know what is the integral of dx over x. It's ln absolute value of x. We replace and we get the answer. So this is for the area. Now we're going to move for the volume. Also for the volume, I have three formulas. The volume of a solid of revolution formed when y is equal to f of x, which is continuous. So the function should be continuous on the interval where I'm trying to find the volume. In the interval a and b is rotated 2 pi about the x-axis. So if I'm trying to find the volume of a solid that it's rotating about x prime x, so it's rotating like this. Okay, so the formula is the following. It's pi integral between those two numbers, a and b, of y squared dx. So How are you gonna memorize it? When I'm doing the area about the volume, sorry, x-axis means it's dx. So it's gonna be y squared. And if I'm doing the volume of the solid of revolution, sorry, about y prime and y, they need to give me two values of y, and the function should be continuous over the interval. It's pi integral between c and d. I said y-axis means dy of what? X squared dy. And if I need to find the volume between two functions, it's like the area we find the integral between the upper minus the lower boundary. So if it's with respect to x prime or x, it's pi between a and b of f squared x minus g squared x. So if f of x, it's here bigger than g of x, it means f of x it's above g of x. So it's gonna be f squared of x minus g squared of x dx. And if I want to find the volume with respect to y-axis, it's pi integral between c and d of x1 squared minus x2 squared dy. Let's do 3 examples for each one. So if I want to find the volume of the solid formed when the graph of the curve y equal e1 minus x in the interval 0, 1. So I know when they say like this, it means the integral is between 0 and 1. About the x-axis, it means dx. So it's going to be y squared dx integral between 0 and 1 of y squared dx. So, and then it will be a pi 0 and 1 e1 minus x squared dx. Squared means it's e2 minus 2x. And then here, to do this integral, we know the formula, we need to change the variable. Let u be 2 minus 2x, du gonna be minus 2x, so du over minus 2, it's dx. So as I'm saying here, it's eu du, but we have the half minus half outside, so it's gonna be minus pi over 2 eu between 0 and 1. I replace and I will get the answer. The unit is cubed for the volume. Another example. Now I need to find the volume of the solid of revolution formed by a rotation, by the rotating the region enclosed by the graph. I have the graph and the line y equal to 0.5. I have it, it's here. And the line y equal to 3. About the y-axis, so it's like it's turning like this. When I say about the y-axis, means it's dy. The formula is x squared dy. And but the formula given, the function given, it's y is equal. So you need to calculate x in terms of y, or even x squared in terms of y. So if I cross multiply, I will get 2y is equal x squared plus 1. X squared is equal to y minus 1. I don't need to write x is equal radical, because what I need, it's really x squared. And then I just replace. There is a typing mistake here. It's dy. And then I just need to calculate the area. What is the integral of 2y dy? It's 2y2 over 2 minus y. And then I replace, and I'll get the final answer, u cubed. The last example is the volume between two functions. So I have here two functions, f of x and g of x. The green is f, the purple is g. I need to find the volume if it's rotated about the x-axis. When I say x-axis, means dx. It means it's f upper minus lower. Who's upper here? It's f of x minus g of x squared. And then I have it, I will square. So it's x over 2 minus x4 over 16. Normal integration, x2 over 4. And this one is going to be x5 over 5. Here times 2 times 16. And then I just replace, and I will get the answer. And now if I want to find it with respect to y, to the y-axis, it means I need to find x in terms of y. So here, to be able to find x in terms of y, I will square both sides. I will have x is equal to y squared. And the other one, I will have x squared equal 4y. I left it like this because what I really need is x. Now, as I said, it's upper minus lower, but now I need to look at it from this here. And this one is flipped. Who's the up here with respect to y? This is y. So this one is below and this one is up. So upper minus lower. So this is upper. So it's g of x. So it's 4y minus f of x, or minus x squared, I mean, minus 4y 4. And then also I do the integral, and I will get it's integral between 0 and 1. Be careful, look at the y. It's between 0 and 1 of the upper. This is the upper minus the lower, and I will get the answer. In the preceding here, it was integral between 0 and 2 because the x was 0 and 2. That's it for this lesson, guys. It's very easy. Sure, we're going to do more application in the class.